Hi everyone, welcome to my channel Math with Miss Sabrine. In this video we are going to look at the laws of exponents and how to solve exponential equations without using logs. So let's go over some basic properties first. Number 1, what is x to the power of 7 multiplied by x to the power of 3? X to the power of 7 means you have 7 x's, that is 1, 2, 3, 4, 5, 6, 7. And then x to the power of 3 means you have 3 x's, so x, 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 x. Now if you count the total number of x's, you are going to have x to the power of 10. So we can say that when you multiply two terms with the same base, you can just add up the powers. So our first rule is a to the power of m a to the power of m times a to the power of n equals to a to the power of m plus n. If you look at this, 7 plus 3 will also give you 10. So you don't have to do this every time. You can just add up the powers. Number 2, what happens when you divide x to the power of 5 by x to the power of 2? Now, x to the power of 5 means you have 5 x's, 1, 2, 3, 4, 5, divided by 2 x's, 1, 2. Then you can easily cross out this 2 x's. So you will just have x to the power of 3. So we can say that a to the power of m divided by a to the power of n will give you a to the power of m minus n. If you look at this and just subtract the powers, 5 minus 2, you will also get 3. So you don't have to do this every time. So this is our first rule. Let me just draw a box around it. This is our second rule. Now let's move to the third rule. Number 3, what happens when you raise anything to the power of 0? X to the power of 0 will give you 1. It doesn't matter what number you take. It's always, if you raise anything to the power of 0, it's always going to give you 1. For example, 10 to the power of 0 is 1. 2 to the power of 0 is 1. 5 to the power of 0 is also 1. So we can say that this is our general rule for number 3. 8 to the power of 0 equals to 1. So this is the third rule. Let's move to the next one. Number 4. What is x to the power of 5 raised to the power of 2? What does this mean? It means that there are two terms of x to the power of 5. This equals to x to the power of 5 times x to the power of 5. Now we already know that when we multiply two numbers with the same base, you just need to add up the powers. So this will give you x to the power of 10. So we can say this actually equals to, the general rule for this is a to the power of m. And if you have a number outside raised to the power of n, this is also the same thing as a to the power of m times n, because you can see 5 times 2 will also give you 10. So you don't have to multiply, you can just write this straight away. Okay, so this is my fourth rule. Let's move to the fifth rule. Let's look at negative exponents now. If you have x to the power of negative 5, all you need to do is to just take this term and move it to the bottom to make it positive. So this equals to 1 over x to the power of 5. So we can say a to the power of negative m will always give us 1 over a to the power of positive m. This is the fifth rule. Now this is also true if you do this. Like if you write 1 over x to the power of negative 5, this will also give you x to the power of positive 5 if you move it upwards. So we can say that 1 over a to the power of negative m is also the same thing as a to the power of positive m. So this is kind of the same thing. If you remember one, you will always remember the second one. Now let's move to the sixth rule. The sixth rule is about exponents that are fractions as well. For example, x to the power of 2, a half. What does it mean? It means that this equals to root of x. If you have x to the power of 1 over 5, this also means 5 root x. So we can say the general form of this is x to the power of 1 over n equals to n root x. So whenever you have a root, it's just same thing as like the power of it, but reciprocal. So 1 over the root. This is one rule. Now, what if we have square root of x, but we have some number outside? Like if we have square root of x and then we have a 3 outside. What does it mean? We know already that the power of root, this equals to 1 over 2, but you also had a 3 outside. We already learned this before. If you have like a power raised to the power of something, you just multiply the powers. So this equals to x to the power of 3 over 2. So we can say that if you raise any, if the base of something, if you have a base a and the power of the base is m over n, you can say that this equals to n root of a to the power of m. Now this form is called the exponential form, and this form is called the radical form. Sometimes in the exam they will ask you to convert from one form to the other, so you need to know the terms as well. Okay, now let's have a look at exponential equations now. Let's say that you have x to 10 to the power of x. Just give me a second. Okay, let's say where's my blue color? Okay, there it is. Now let's have a look at exponential equations. Let's say I have 10 to the power of x. This equals to 10,000. If we can write down both the numbers with the same base, then we can just equate the powers. For example, 10 to the power of x, there is nothing to simplify, it's just that. But instead of 10,000, this can be written in terms of 10. Like you can write 10 to the power of 1, 2, 3, 4. 10 to the power of 4. This is the same thing as this one. So whenever you have the same base, you can just solve for the power. In this case, it will give us x to the power of 4. Let me show you another example. What if we have 5 to the power of x equals to 125? This number you can't simplify it anymore, but this 125 you can actually write it as 5 to the power of 3. So when you have the same base, you can just say the powers equal to each other. That means x equals to 3. Okay, so these are some easy examples. Let me show you something that's a little bit difficult. So what if I have 3 to the power of 2x minus 1 equals to 27? Now this 3 you can't simplify it anymore, but instead of this 27 you can actually write 3 to the power of 3. Now you have the same base. Now you can solve for the powers. This will give us 2x minus 1 equals to 3. 2x equals 2. I will move this one to the other side. This will give me 4. So if you divide both sides by 2, you will get x equals to 2. Let's look at another example that is in fraction form. Okay, 1 over 3 to the power of x equals to 9 to the power of x plus 1. Now look at this. When you don't have a power, it just means the power is 1. So if you move it up, this power will become negative. We just studied this rule today. So the power of this, if you move it up, it will become negative 1, but you also had 1x outside, so it will be there. For 9, you can actually write it as 3 to the power of 2. Inside the bracket, you will have x plus 1. Now let's look at the power. We have the same base. For this power, I can write this equals to. You just need to multiply the powers. Negative 1 times x will give you negative x. This equals to 2x plus 2. I will move this 2 to this side. I will have negative 2, and I will move this negative x to that side. So 2x plus x will give me 3x. If you want to find the value of x, all you need to do is just divide both sides by 3. These and these gets cancelled out, so I have x equals to negative 2 over 3. This is the answer for this question. Okay, so that's all. If you like my video, then don't forget to subscribe. See you next time. Thank you.